Good afternoon, everyone. Thank you for stopping by the Madison Museum of Contemporary Art for this afternoon's discussion, Chasing the Stars, the Women Computers of Washburn Observatory. Today's talk is presented in conjunction with the exhibition Imaginary Eye on display in the museum's main galleries through April 7th. The exhibition explores how artists, scientists, and mathematicians explore and seek out unknown worlds and concepts, projecting future and undiscovered realities, and reclaiming, retracing, and revealing the patterns around us. I'd like to begin with an acknowledgement of the Ho-Chunk people on whose ancestral land Madison was built, and also recognize the 11 other First Nations of Wisconsin. Now is your opportunity to silence all cell phones and electronic devices, but while you're checking the volume levels, feel free to quickly open your favorite social media app and follow the museum at MMoCA Madison to stay in the loop about other upcoming events. Today is International Women in STEM Day, set aside to honor women's significant achievements in science and ensure equal access and participation for girls and young women studying science, technology, engineering, and mathematics. Erica Blumenfeld's Tracing Luminaries series, included in Imaginary Eye, takes inspiration from the Harvard Computers, a group of women in the late 1880s who were prevented from participating in traditional academia, yet through their detailed notes and cataloging of thousands of stars and other astronomical phenomena, they revolutionized the science of astronomy and astrophysics. Since 2005, the Harvard-Smithsonian Center for Astrophysics has been digitizing their plate collection. However, during the scanning process, the plates were wiped clean of notations, literally erasing the women's contributions to astronomy. The symbolism immediately compelled Blumenfeld to respond, preserving their notations through art and poetically returning their lost marks to the stars once again. Erica will be giving a virtual gallery talk on April 4th about this subject if you are interested. These Harvard computers were not the only women who contributed to the astronomical findings at a time when they were barred from using the telescope, or voting, or holding elected office, or working most jobs. The Washburn Observatory on UW-Madison's campus was constructed in 1877 and housed the third largest telescope in the United States at the time. It remained a major research facility for the next 80 years, not only contributing to scientific breakthroughs, but inspiring thousands of space lovers throughout the state. Today's presentation will focus on the early days of astronomy studies in Wisconsin, emphasizing the role of female astronomers and their contributions to astronomic research. Jim Lattis manages the historic Washburn Observatory and is the director of UW Space Place, the Outreach and Public Education Center of UW-Madison Astronomy Department. Kelly Tyrrell is a science writer who oversees media relations for UW-Madison and serves as engagement editor for the science journalism nonprofit, The Open Notebook. Their book, Chasing the Stars, How the Astronomers of Observatory Hill Transformed Our Understanding of the Universe, will be released in May. Please join me in welcoming Jim to the stage.
Thank you, Bob, and thank you very much for inviting us to give a talk today. This is Kelly, and Kelly will be taking sort of the second half. So yes, we're going to talk about women's contributions to astronomy in a couple of different contexts, part of which will be referring to the Harvard computers and classifiers that are central to the Tracing Luminaries exhibit that you can see upstairs. And we're extracting some material. In fact, really, this is the first public appearance, I think, of any of the material from the book that is coming out in May about the history of Washburn Observatory and about UW astronomy more generally. So why do we have an observatory here at all? We would have a building named Washburn something, one way or the other. Why do we have an observatory named after Washburn? Cadwallader Washburn was the governor of Wisconsin and retired from politics, had a lot of money, and wanted to give a major gift to the university. Proposed, we think, maybe to build a new library for the university. But the reason we've got an observatory is because of John Bascom. John Bascom and the faculty members of the time conferred about what they should do with Washburn's generous offer. And they wanted an observatory. This was the height, the 1870s, of what historians call the American Observatory movement. If you look, there's observatories cropping up all over the place in the United States during that period. It was both a status symbol, but it was at the forefront of science in those days. The understanding of the solar system in gravitational terms, and the understanding of the stellar system, the arrangement of stars, what we these days would call the galaxy, things like that. Washburn Observatory was built because the university wanted a research institution, because Bascom and the other members of the university shaping the university at the time had it in mind that the university should move in the direction of a research university, a relatively new model in that period. So the university, under the impetus of Washburn and Bascom, moved in the direction of emphasizing research in emulation of places like Harvard and Johns Hopkins and MIT, which were already pursuing those models. Michigan, too, is a good example. So if I leave you with nothing else today, please note that you can visit Washburn Observatory and look through the telescope on the first and third Wednesday nights of each month if the sky is clear, and in the summers every Wednesday night, June, July, and August. That pattern, we've been doing that since spring of 1881. So it's a long tradition that we keep to. So we have it because Cadwallader Washburn wanted to give a gift to the university, and we have an observatory because the university wanted to move in the direction, specifically Bascom was very important in this, moving the university in the direction of a research university. What kind of research did they do there? Astronomy in those days, to characterize it very broadly, was largely aimed at the determination of positions of things on the sky. And this is this is fundamental to a number of scientific investigations. The positions of things on the sky were investigated with two major instruments, and you will find this pattern at most observatories that are contemporary. There's the telescope we all think of, the one in the dome there, which the astronomers would call the equatorial. It could point anywhere in the sky. You could look through its eyepiece at a comet or a planet or something. You could also look at double stars, and you could measure very carefully the positions of double stars. And if you did that over a period of decades, you could figure out the orbits of stars that we would call binary systems, stars that are bound together. And all kinds of important information can come out of that, like the masses of those stars, for example. The other instrument you can't see here from this view, it was in the west wing of the building, and it was an instrument called a meridian circle, which was a special type of telescope, a specific type of something called a transit instrument. I won't go into that, but its point was to measure positions of stars on the sky very accurately by watching them cross the meridian. Watching a star cross the meridian, the telescope could tell when a star, well, the astronomer could tell when a star crossed the meridian, measure that time very exactly. You can turn that into an east-west measurement, and the orientation of the telescope up or down. And from those things, they measured things like stellar parallaxes, which gives the distances to stars. And in those days meaning up until the early 20th century, only a handful, 50, 100, 200 stars had parallaxes that were known, which gave astronomers distances to stars. That's fundamental to understanding their physical characteristics. These kind of position measurements were critical. I'm not even going to talk about star catalogs and things like that. You had to have catalogs of stars of high accuracy to get you to these other sorts of measurements. All of that means that the astronomers at night would be measuring the positions of things in the sky and writing down the results of their operations. So they're at the eyepiece, they're making a time measurement. Maybe this is actually from, I think, Greenwich. This figure up here shows a guy using a meridian circle telescope, and perhaps this guy is reading the meridian circle itself, and I don't know, this guy might be reading a clock. The measurements that they came up with would be recorded in notebooks over here, and then you had to have the data reduced. So these raw measurements that come from a night of observing have to be turned into things like actual positions on the sky, or actual rotations of these of these binary star pairs, for example. And so here you see an example of an observing notebook that we borrowed from the UW archives, open to a page. They were kind enough to lend us the notebook, which you can examine yourself if you want to afterwards. It's on the table up here. This one, it contains entries, though, by Alice Lamb. It says Miss Lamb right there, by Alice Lamb, who was one of the female astronomers, about the only one in that period who was actually doing measurements up at actual observations up at Washburn Observatory. It was much more typical for women to work at observatories in daytime roles. And the Harvard classifiers and computers have been written about a lot, for they're associated with really important scientific work that went on up there, including classifying stars, making really the first version of the modern star classification system that astronomers still use. And also doing some really important work there studying variable stars, which turned into a way to measure distances of stars. Henrietta Leavitt was known for that. So they were doing a lot of work. This was daytime work. Now, in the case of the Harvard observers were taking photographs at night, at least of stellar spectra in the case of that work. And you can see down here in the lower right, Annie Cannon, who was one of the leaders of this group, examining a photographic plate. That's what she's looking at right there in that frame. I'll show you a better picture of one in a moment. That kind of classification work was unusual and unique to Harvard in that period. Much more common was the kind of work, again, going on back here at Wisconsin, where the observational data was turned into scientifically useful results by a process called a spreadsheet. And there you see one. If you've never seen the physical kind, there's one. And each one of those columns, you probably can't read this very well, each one of these columns has the name of a star. And then there's the data from the observations made on that night. And then the spreadsheet defines the calculations from column to column until you get down to the bottom, and then you get the answer. You got the result you want, which in this case is an accurate value for the declination of the star, meaning its location north and south on its north-south coordinate on the celestial sphere. So this was work to be done in the daytime, taking just the data that the observers had collected here at night and turning that into a result then that maybe you'll publish or use for further analysis or something like that. One of the things that you might get from data, from this kind of data reduction, from these positional measurements, a really important one, as I mentioned, was binary stars. This was not done at Wisconsin, but this is one of the prettiest examples here of the orbit of one star about another. This one is Alpha Centauri, which we don't see from Madison, so that wasn't done here at all. But that kind of information is what you would derive from those hours and hours of observations, followed by hours and hours of computation, literal computation. That's what the computers were doing at Washburn Observatory. Up at Harvard, they were looking at, among other things, they were looking at photographic plates that contain the spectra of stars. And those black blobs there, they're really poorly reproduced here, but each one of those is the spectrum of a star. They could look at those and figure out, put them into classifications, various sorts of classifications that are useful to astronomers. And they cataloged hundreds of thousands of stars up there at Harvard ultimately over the decades. Some of those glass plates might be in the tracing luminaries upstairs, but the ones that I could recognize, and from the notes, they seem to be more associated with the variable star work of Henrietta Leavitt, but it's a little hard to tell entirely just what they're doing there. What you don't see when you look at the tracing luminaries are those where it says like B0 and OA and K0 and so on. Those are notations on there of spectral types. And you would have expected to see that on those plates, except those may be printed on afterwards. So maybe we don't see those, but I don't see any of those objective prism plates upstairs in tracing luminaries. Well, the Washburn computers, including Alice Lamb, who I already referred to, the Washburn computers are well documented in the really early period in the 1880s and 1890s, and Kelly is going to tell us some specifics, get us acquainted with some of those women who worked at Washburn Observatory.
Thank you, Jim. So women were pivotal to astronomy in the late 19th century, not just at Harvard, although they're probably some of the best known. Washburn Observatory had a fleet of women who were really pivotal to making some of the early findings at Washburn and really contributing to advancements in the field of astronomy. And as Jim has already laid out, the work here was a little bit different than what was happening at Harvard, where women were actually analyzing the photographs the observers were making at night, leading to the classifications and cataloging a lot of these stars. Here in Madison at Washburn, the women were doing a lot of the actual computational work, a lot of the equations, and translating those observations into publishable data. Again, they were working mostly in the daytime, although Miss Lamb, as she refers to herself in her documentation, you'll see in the notebook if you have the opportunity to take a look in a bit. Most of them were still working during the daytime doing these mathematical tasks. But without them, and without the male students as well, who were also participating at the time, I don't think we want to give the impression that there were not also male assistants who were serving these roles. Women just were uniquely positioned in astronomy during this era. But without them, most of these results would not have been publishable. And so really we start to see women begin to be hired in the earliest days of Washburn's existence with its second director, Edward Holden. He really took a liking to hiring women. He thought they were skill-wise equivalent to, if not superior to, the men for their fastidiousness and their careful calculations. And he was hiring women and men, making about 25 to 50 cents an hour. And at the time, the observatory was, as Jim alluded to, literally selling time. So using this meridian circle methodology, where they were getting very accurate transits of the stars, they could keep accurate celestial time. And that was really valuable to the railroads, who wanted to keep schedules on time, and to banks in particular. This service, though, did dwindle down in the 1890s, as you might imagine. And so we're going to take a little journey here and meet some of the women. I do want to say that we're by no means giving you a comprehensive view of all of the women who may have worked for Washburn Observatory in the late 19th century into the early 20th century. But the records are relatively sparse, and we simply haven't been through every possible piece of archive as well. But thought we could introduce you to a few of them today. So Emma Gattaker was hired alongside Elizabeth Schofield, who we'll meet in just a moment. And they were working on a project for Holden to catalog stars in sections of the southern sky, using observational data actually from the U.S. Naval Observatory. Emma is from Baraboo, and in 1881, she earned her bachelor's degree in science. So this also might be a surprise that UW-Madison was also awarding degrees to women in the 1880s. I'm going to go off script a bit here, and I want to say that Bascom's daughter, Florence, also was the first female graduate student. She earned a PhD in geoscience in roughly the same era. So back to Emma. What was Emma doing as she's working on this star catalog project for Holden? She's working for about $20 a month. And unlike her male counterparts, she was actually offered lodging in the observatory residence with Holden and his family. The men were earning a little bit more, about $25 a month, but they were relegated to more rustic quarters. They were either living in the observatory itself or in the Watson Solar Observatory, which we can go back if you'd like. There's a photo of that solar, a rendition of that solar observatory. In an earlier, it doesn't exist anymore, so don't go to Observatory Hill and look for it. But Gattaker also, in addition to her computational work at Washburn, knew German, and so she was relied upon to use her skills, her German language skills, to translate publications and notes about the making and characteristics of lenses for astronomical telescopes. So the assistants brought all kinds of skills to their work. Alongside Emma was Elizabeth. Elizabeth was from Wausau. She also earned her bachelor's degree in science in 1881. She was working on the same star catalog project as Gattaker. And what they were doing together was they were transferring data from the observing notebooks into those spreadsheets that Jim showed a picture of. And courtesy of archives, we also have a spreadsheet for you to peruse at the end. But from these spreadsheets, they were doing then whatever calculations that the spreadsheet was designed for. So they would have equations and other things that they would be plugging these numbers into. So they would, for example, be taking some of the raw data from the meridian circle and translating those into celestial coordinates so that they could be plotted on a star chart and used in these star catalogs. Holden estimated that the women, just these two women, Emma and Elizabeth, would have written about 3 or 4 million digits between the two of them for this project. A little later was Alice Sanborn, but also contemporary of Emma and Elizabeth. She is not from Wisconsin, she's from Freeborn, Illinois, but we'll forgive her for that. She earned her Bachelor's of Letters in 1883 and also got a graduate degree in English literature in 1886. She was also entrusted to work on observatory instruments. So again, women were also sort of an all hands on deck at a time when funds were relatively limited and there was a lot of scientific potential at the observatory. Alice also wrote and published in the publications of Washburn Observatory using her own name. She also in 1883 or maybe 1884, the record's a little bit unclear, she won a student essay prize called the Lewis Prize, and unfortunately we don't know what the topic of her essay was, but we do know that in 1881, she was part of the Loran Society, which was a student group on campus, and she gave an address on the theme of ambition, and she related her essay to the university's new 15.6-inch refracting telescope. So she was certainly a force. And Holden actually encouraged her to study what he called the higher principles of astronomy, though her career does not seem to have continued in astronomy. As time went on. Alice Lamb, however, she, like Sanborn, was published under her own name in the publications of Washburn Observatory. She was working alongside one of those male assistants, Milton Updegraff, who ultimately became her husband as well. The two of them served as Holden's last student assistants before he left to go run Lick Observatory in 1885. Basically, between Lamb and Updegraff, they kept the observatory running, and a new director was not actually hired at Washburn until 1887. So for about 2 years, they really kept things going. Together, they published Volume 4 of the publications of Washburn Observatory, which really represented the only significant research results from this period. As Jim mentioned as well, Lamb was not only working on the spreadsheets during the daytime, but she was also at the telescope at night. She also ran the university's time service, and she was cited by Sherburne Burnham, who's well known for his binary star catalogs, and he mentions her in his 1900 catalog, so she also made an impression. Later on, she was offered a position running a small observatory in present-day Yankton, South Dakota, but we included a quote from her here. She says, "I refused the offer, partly because I had far rather work in a true observatory than direct a toy one, and partly because I felt at any rate in a measure bound to stay here until March. Of course, I should be glad to stay longer." Miss Lamb did want to stay at Washburn, but she and Milton ended up moving to Cordoba, Argentina, where he had a job with the Argentine National Observatory. She briefly had charge of the time service there, but when Milton's work brought him back to the US, she came back with him, and her astronomical career seems to have fizzled out from there. Edna Hill worked with Albert Flint, who was director of Washburn from 1909 to 1916. So now we've jumped ahead in time a bit. Flint was engaged in this painstaking work trying to measure discrepancies in the apparent position of stars. So because the Earth is moving in its position relative to the sun, the background of the stars that are apparent from Earth is also changing. And so this is the stellar parallax, is trying to account for these discrepancies. And this instrument, the filar micrometer, allowed really precise measurements of the position angle of stars, and it helped reduce the variation. And so each observer had to sort of make corrections, right? Because everyone has sort of a different perspective. And so each person had their sort of personal equation, this correction to sort of correct their measurements. So Edna was working with Albert Flint during this period. And so she would have been taking the observations that he was making via electrical signal. Using a ruler, she'd be making those measurements. We don't know a whole lot about Edna. She had a degree when she started working at the observatory from Capital City Commercial College and had been working as a school teacher. She started working at Washburn in 1908. She seems to have made a pretty quick impression because her salary was raised after 1 year on the job from $600 to $720 a year. Because, quote, she had become proficient in the routine computations of the observatory in large measure, taking the place of computers hitherto employed by the hour. Later, Director Comstock tried to get her a raise, and unfortunately the funds were not there to make that happen. And now we jump quite a bit ahead to Edith Flather, who was working with John Mathis and Rudolf Minkowski around 1960. She was what we would now call a programmer. So by 1960, we have gone from, women making calculations on spreadsheets to women actually working with the kinds of computers we think about today. It's important to note that Edith is by no means the only woman since 1960 to work in astronomy at UW-Madison. But in Schofield and Lamb and Sanborn's day, to be a woman in astronomy was to be uncommon, notable. That's why we're here talking about them today. But thankfully, today, we don't talk about female astronomers or lady assistants or women computers. Women are much more prominent and continue to make pivotal discoveries today. And you're going to hear a little bit now about a modern day astronomer who also happens to be a woman and also happens to be in this room.
Well, so we're just going to close with this. This was just in the news at the latest American Astronomical Society meeting, and it's one of these exciting results that is coming along these days. Exoplanet science, the discovery of these planets orbiting other stars, and there was an announcement about a particularly interesting one that made the headlines, which has as its one of its lead authors Melinda Suarez Furtado, who happens to be sitting out here in the audience as well. And one of her colleagues is Alyssa Jankowski, who's also here, who did this wonderful graphic of the, and is a co-author on the paper as well. She's back there too. So I'm going to let you talk to them about the science if you want to afterwards, but we wanted to end with this to sort of indicate what sort of direction roles in science for women have what sort of arc they've followed here from the early, very restricted sort of roles up till today, where they're an important part, very important part of astronomical science, an essential part, I guess we'll say. We have, as I said, just chosen a few of these stories from our forthcoming book. And so if you're at all interested afterwards here, we'll take a few questions. I think we have time for a few questions here, but you're welcome to come up here after we get done with that. We do have one of the observing notebooks up here that we borrowed from archives that has some of Alice Lamb's work in there, and we have a couple of these spreadsheets up here on the table, and we also have little cards about the book that you can take away with you if you want a reminder for when it comes out in May. So thank you all very much for coming today, and I think we should take questions if anybody has any. Yeah, Bob.
Just a comment to also finish up. Our department now is, I believe, the only department in the United States, astronomy, that has a majority of women faculty. Which is something we've been very intentional about and are very happy to be able to say.
I don't know if everybody could hear that. Bob Matthew, and the professor in our astronomy department, says that our department has a majority of women faculty, and you say that we may be the only such department?
I'm pretty sure we're.
Interesting. Yeah. Cool.
Yes? Okay. Jim, I feel like I should know this, but Washburn was doing glass plates, weren't they? Glass photographic plates?
At Washburn Observatory?
Yeah. They were not.
Not really. So this positional astronomy that I roughly characterized was the main work of the observatory until about 1920. And then with a change in director, a guy named Joel Stebbins was hired to replace Comstock when Comstock retired. And Stebbins took things in a completely different direction, basically doing electronic measurements of light. Photoelectric photometry is what we call it. And that characterized the work. That was the main research for many years using that technology. Not the science. I could tell you about the science, but and the book tells you about the science. But the Stebbins was fond of saying that Washburn Observatory just skipped the age of photography completely, which is more or less true until a new observatory, namely the Pine Bluff Observatory, came along, where they then had an instrument that recorded spectra on glass plates. That was in the late 1950s. From the 20s to the late 50s, Wisconsin photography was not all that important as a scientific technology. Fortunately, they did take a few snapshots, which we have around, so photography was used that way.
Is your book available for pre-order now?
Yes, it is.
Yes, it is. In fact, let's see, go.wisc.edu/Chasing the Stars book. There's a note on the poster up here. Thank you for asking, Siri. The book is out May 7th.
There it is down there.
Mm-hmm.
So in the era you're talking about, did they have any kind of calculating machines, or was it all just done by hand?
Well, so in the late 19th century, they had mechanical calculating machines basically that would add and subtract. And that was a big part of it because astronomers add and subtract logarithms a lot. So that was a good part of things. And then in the early 20th century, the technology started coming along for machines that could do multiplication and division, although they were complicated and expensive. But we had a couple of those. I don't think we have any from those days. The oldest calculating machine that we have that belonged to the observatory, I think, dates from the 1950s. So they were using those, though, because it's in the correspondence that they're using a certain type of calculating machine. But it's also a good bit of work looking up logarithms or trig functions in a table. We have at least one really remarkable slide rule that the astronomers seem to have been using, not just your little high school slide rule, but a complicated thing. So there are a number of technologies that went into this kind of work.
But no TI-83 calculators.
I'm curious how collaborative the work was more broadly beyond Washburn with other observatories, or are observatories largely working on sort of individual projects and just beyond the publication and what's shared in that way, not collaborating? Yeah.
So you mean collaborations between Washburn Observatory astronomers and other observatories? In those early days, in the late 19th, early 20th century, it was pretty self-contained. And you actually kind of see that in the way that astronomers publish. We mentioned a couple of times the publications of Washburn Observatory. Observatories would publish their own results every year, and everybody exchanged volumes. But in the early 20th century, the importance of journals and things like that start coming along. So you begin to see much more dialogue, much more interaction with astronomers knowing in a much more timely fashion what's happening at other observatories. I think that's when collaboration starts to become important. Although certainly it was there. They would, for example, Comstock collaborated with a couple of other observatories in longitude determinations. You need to know the location of your observatory pretty accurately. They were experimenting with ways of using telegraph signals and radio signals ultimately. But generally speaking, the scientific programs were pretty focused, pretty parochial.
And at that point too, funding was very much on privatized, right? It was the reason Washburn existed because a wealthy businessman who also happened to be governor decided to give the observatory money. I think Jim referenced a popular book by Davis Sobel, The Glass Universe. Full disclosure, I'm reading that book right now. It's really good. Highly recommend it. But really, they kind of, Dava walks through in her book this period of time where most of the discoveries being made by the female computers there were because of wealthy female benefactors who were giving money to the observatory at the time, including Henry Draper's wife. So Henry Draper is responsible for this major star catalog. It's the HD in front of the solar bodies or celestial bodies here, and you notice in the parentheses that the star first appeared in the Henry Draper catalog. So it was Henry Draper's wife who, after his passing, started basically funding the research at Harvard. And so there was not a lot of maybe nationalized reason either for collaborations to happen. But things were starting to change in that period. We got one in the front after.
You mentioned that timekeeping was one of the main products. How did they actually deliver that? Was that by calibrating clocks that they then sent out, or was there some other way that they transferred that information to the railroads?
Yeah, good question. So they did astronomically set the master clock at the observatory. And then they had actually two standard time clocks. The master clock at the observatory is what they call a sidereal clock. It keeps time by the stars. You set that from your observations. It's then used to set the standard time clocks, and they were set up with telegraph lines. They were connected to telegraph lines. And every day the policy changed a little bit from time to time, but like roughly 10 a.m. on every day but Sundays, the subscribers to the Washburn Observatory time service could connect to the telegraph network and listen for the signals, which were basically ticks. If you've ever listened to WWV or something like that on the radio or something like that, that was it was a lot like that. Ticks on the telegraph that you could interpret as time signals. So a couple of minutes before the hour you connected, you would hear a signal, tick, 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 and then they would skip the last couple of seconds before the hour. So you'd be listening, and then suddenly there's a couple of ticks that you miss, and then the next one marks the exact hour. So those ticks were coming from the observatory clocks over the telegraph lines. The railroads paid about $100 a year to receive accurate time signals. And that was a pretty important source of income to the observatory up until it began to dwindle out in the 1890s for various reasons. But that cash, that income above and beyond the budget that the university, that the observatory got from the state, funded a lot of student assistants, including both calculators and night assistants who helped with the observing. Also, weather was a big one.
I have a couple questions about the building itself, as it's portrayed in this really lovely cover illustration and the photograph that you showed before that it appeared to be based upon.
Yeah.
Can you orient us toward what angle we're looking at this from? Because it appears to be before some additions to the building, so we can kind of compare that as we look at it in present day life.
So this is the view from the east. It's if you imagine, if you know the campus, if you were on, basically if you're at the La Follette School, this was probably taken from the roof of the La Follette School. But if you were, say, in Van Nuys Hall or something like that, you'd be seeing this side of the building. So you're looking westward, and you see.
Sorry, I've been trying to catch that before it happens. But.
Yeah, it's okay. So the building as you see it here was pretty much as completed in 1881, but there are a couple of pieces that you don't see in the other photograph. Will it go back to that far?
So Lake Mendota would be to the right?
That's right. The lake is to the right. There was a small student observatory right over here that you could see in the other, the first photograph that we used. There was the small student observatory on the right, And on the left, the Watson Solar Observatory is really hard to pick out there with the cursor. The Watson Solar Observatory, you can barely see it right down here. That's its roof, this white patch here. It's on the hillside right down there. And you can read about it in the book. There's a long story about why that's there and what happened. But that building is long gone, although they did use it to house some of the observatory assistants for a little while. So you can see photograph was taken in the spring of 1881. So the observatory was on the western edge of campus. All the land beyond there is what they used to call the university farm. It was, I forget how many acres, maybe 100-ish, a pretty good plot of land out there for the ag school to use.
So today you'd be seeing the medical complex in the distance.
At what point in history did the growth of the campus and the growth of Madison and the light pollution from buildings and so forth make it impractical to continue the research at this location?
So it's a little complicated. By the early 20th century, by about 1910, George Comstock, the director then, was very seriously looking at alternatives for relocating the observatory. The idea then would be to move the telescope, build a new building, and they actually had plots of land identified, some of which were actually acquired then by the regents, with the partial possibility that the observatory might end up there. A place called Eagle Heights, for example, was one of these possible locations. But Comstock eventually decided that he didn't want to get into that unless he could also get an upgrade of the instruments. He basically wanted a new observatory. And that didn't happen until the 1950s. So by the 1950s, the campus had swallowed up the observatory, and lights, of course, but what we don't think of so much today, coal smoke was a huge problem. And the campus just made photometry hard to do because these plumes of smoke. And despite that, they continued to do science with that telescope until the late 1950s, when the Pine Bluff Observatory, the kind of science was one of the earliest things they did with photometry, which was measuring what are called eclipsing binary stars, eclipsing variable stars. You could still do that with that telescope from the middle of campus, but all the other stuff had to be done out with new telescopes and new instruments and things like that. So it was an evolving sort of thing. The sky had begun to degrade in the early 20th century, but the need for a new observatory wasn't answered until the Pine Bluff came along in about 1958.
Do you want to mention where Pine Bluff is?
Pine Bluff Observatory is about 20 miles west of Madison, just outside of the little town of Pine Bluff that you run into if you drive out Mineral Point Road.
So, I know that in your talk, you just selected a handful of the women astronomers and assistants and computers, et cetera. But I did notice that you have a sort of a gap, basically starting at the Stebbins photometry era. Was that a coincidence, or did the sort of changing nature of the work being done at Washburn impact the whole sort of practice of hiring assistants in general, or women in particular, or can you say anything about that?
So it's mostly what you saw there is determined by what we can find in the archives. And I know from correspondence that there were women working as computers in that role, identified that way, right on up into the 1950s. But we don't have lists of names. We just have references to, or a lot of times it's hiring. The letter will say, we need to hire a new one. Well, I don't know who they're replacing and who they're hiring. I just know that position is existing, so that kind of work is going on. I only know one name from the 1930s, and that's because it was Elizabeth Huffer, who was married to Morse Huffer, who was one of the two astronomer staff at Washburn Observatory. So she crops up. I know her name because of that, and we actually can know a little bit about her biography, but in her case, I can't find out what dates she actually worked there. I only know that she did work there because she said so in her memoirs, but she doesn't say, give us any details. So it's very sketchy, and we've just pieced together where we do have individuals or where we do have some information. In the early days of the observatory, they were quite particular there about getting photographs of people on the staff. That seems to have been a thing up until about 1900. And then Edna Hill, who's about 10 years later, Edna's in there, but we don't have any other computers, any pictures of any others, and very few details. Again, Edna Hill's career we know a bit about because she's mentioned she was there for a little while, and there were a number of personnel correspondences where she's involved.
Yeah, and I think some of this is maybe central to some of Erika Blumenfeld's work. The idea that these women at Harvard were taking notations on these glass plates as they were contributing to the observational work and the computational work. And it was standard practice, and Jim's the historian, I've learned a lot from him. It was standard practice, the assistants would take their notations on plates, and then the plates would be wiped clean so that the next slate could be used, because the plates were like any data set that we might have today, right, where at any given point in time you can get certain information from it, and later on you might learn that there's something in that data set that you didn't know was interesting, so you can go back to that data set. These plates served the very same function, and so you might take notations on them in 1883, and then by 1902 something else has happened in the field, and you realize, oh wait, I might have a plate for that, and go back to it. And so some of this erasure was not to erase the contributions of women, and certainly there were male assistants at Harvard too who were also taking notation on these plates. But there was some discussion, as you'll learn if you go see the exhibit, about how to sort of capture that historical record, and in particular the historical contributions of the women at Harvard. Because the record matters.
All right, we have time for one more, I think.
So 25, 50 cents an hour, was that a sacrificial wage, or was that a competitive wage that people wanted the positions?
I wish I knew. They seem to be, that pay rate was about right for a few years. But that is, multiple people seem to have taken it. And the rate would go up and down too with whether somebody was getting lodging. In fact, the solar observatory comes up a couple of times as being, no, don't tear it down, even though the instrument didn't work. It's real handy because we can offer lodging to a student, and then we can pay them less. But whether that, I really don't know whether 50 cents an hour was, they were probably getting help from their parents too to stay in school and things like that. So I don't know. It probably was not a living wage until, again, and I don't have a lot of data on this. The first figures that we talked about there were student assistants. Edna Hill was not a student. She was working. She had a regular staff position at the observatory, and when Comstock filled her position and others, he was doing it through the state civil service process. There are letters where he says, well, so-and-so is leaving, so we're going to need and they would have taken an exam. People with mathematical aptitude, Comstock would say, I need somebody who's actually, got some mathematical skills. And so whether that was a living wage, it probably was what Edna Hill was making in those days, although at the same time, Comstock was making about $2,000 a year when Edna Hill was making $900 a year. So what an apartment cost to rent, I don't know, but making roughly half what the director made is I don't know what it tells us, but it tells us something.
Better ratio than today, probably.
Maybe. I don't know. What is it? Oh, we don't have a director anymore, do we? Oh, well.
All right, well, thank you very much, Jim and Kelly, for this wonderful presentation. Imaginary Eyes on the second floor, and then Erika Blumenfeld's series is in the back right corner if you want to check it out. Otherwise, you're welcome to check out these materials at the table. Just be careful, they are from UW Archives, so we want to be very careful with them.
Yeah, so we can't fit everybody on the stage at once, but if you want to come by and take a look, we'll stand around here for a few minutes.